All right, now let's take a look at another example. Here we have a stone that is tossed straight up off the top of a tower at 15 meters per second, and it hits the ground below 7.10 seconds later. And it asks us, how tall is the tower? So, first step with any problem like this is we're going to draw a little sketch of what's happening. So we have some kind of tower here, right? And we are standing on top of the tower and throwing a stone straight up at 15 meters per second. So if we throw a stone, here's your little stone that we're holding, and we throw it straight up 15 meters per second, and it's going to come down and hit the ground. Okay, so what other information we have? Well, it's thrown up at 15 meters per second, so that means this speed initially 15 meters per second. And the other piece of information is that the ground below is, it hits the ground below 7.1 seconds later. So at 7.1 seconds. And it is asking for us to find how tall is the tower. So we want to know distance is the height of the tower. So what is, that's delta D, the change in position. Now I want to make an important note that the distance we're looking to find is the distance from top of the tower where the stone is thrown to the bottom of the tower where the stone hits the ground. We are not in this question looking at the maximum height. It's not asking for how high the stone reaches, it's just asking for how tall is the tower. So it's just important to note we're going from the top of the tower down to the ground, not to the top, not to the maximum height of the stone. Okay, so now that we have our problem visualized, we are going to move on to step number 1, that is to organize the variables. Organize our variables. So here we can see some information that we're given. Question, an initial speed is initially tossed 15 meters per second. So that means our V1 is equal to 15 meters per second. Let me do this neatly. Another piece of information, and the question is that it hits the ground 7.1 seconds later. So we know the time is 7.1 seconds. And similar to previous questions that we've done, there's a third piece of information that we have that's not explicitly given in the question, and that is the acceleration. So it's a value you're going to have to memorize, and that is the acceleration as long as you are on planet Earth is minus 9.81 meters per second squared. Again, that's a value you're expected to memorize as long as you're on Earth. You have this acceleration that is negative 9.81 meters per second squared. And then our fourth variable, the one that we will be looking to find, our unknown, is the height of the tower. So that variable is change in position, and it's our unknown. Now, moving on to step 2. 2, we're going to be choosing the equation. Choose equation. So we're going to come over to our graph. Well, first we got to see the variables that we're given. So v1, time, acceleration, and change in displacement. So let's run over to our chart here and see, okay, which equation uses all 4 of those variables that we're looking for. v1, delta d, acceleration, and time. So the equation that uses all of those is this one here. Equation, as I've labeled it, number 2. Your textbook or your teacher might have different numbers corresponding to the equations, but here what's important is the equation itself. So you see the variables it uses in the equation. So this is the one we're going to use here, equation 2. So because we have v1, t, acceleration, and delta d, that means we're going to use equation 2. That brings us to step number 3, where we plug in the variables. So plug in variables. And I will make that a little bit neater. And I forgot the 3. Okay. So rewriting our equation from the chart, the delta d is equal to v1 times t plus 1/2 at squared. And now all we have to do is plug in our given variables into this equation. So our delta d, well, that's our unknown. So when we write this in the equation, we're going to keep it delta d. And then our v1, we have 15.0 meters per second, 15.0 meters per second. Then our time, we have time equals 7.1 seconds, 7.1 seconds plus 1/2, and a value for a. Looking back here, it was negative 9.81 meters per second squared, negative 9.81 meters per second squared. And then our time, which we're going to square, again was 7.1 seconds. So 7.10 seconds. All right, and now let's just simplify this equation a little bit. Multiplying out some values. Our delta d, I'm going to keep it green so we can keep track that it is our unknown variable. And when we multiply these two numbers together, it's going to give us 106.5 meters, and I encourage you to practice along with me, typing these into your calculator and writing them out. And then this over here, we're going to plug all this mess into our calculator in one go and get 247.26 meters. So now it just so happens that in this problem, we don't need to rearrange the equation because our unknown is already isolated by itself on one side of the equal sign. So that's going to make it easier for us. All we have to do is type this into our calculator. 106.5 minus 247.26 will give us negative 140.761 meters. And I was carrying over some extra decimals from before, so I've just got a couple extra decimals because I stored these values in my calculator, so it's just little rounding, just little rounding differences, but you'll see in our final answer, we're not going to care about all these decimals because the question, all the values are given with 3 significant digits, so that means in our final answer, we want to rewrite this. We want to rewrite this with 3 significant digits, so that will be negative 141 meters. Negative 141 meters, and that is our final answer. Now let's just think about, okay, what does this mean? So that means, does that mean the height of our tower is negative 141 meters? Well, not exactly, because what we're measuring is actually a distance downward. So we're saying, we're imagining the height of the tower where we stand is 0, and then we're asking ourselves, what's the distance from where we are to the floor, and that is negative 141 meters, meaning that the tower actually has a height of positive 141 meters. So we can write that in a sentence. The tower is 141 meters tall. And that is our final answer.